welcome to another video of Corpnce. I'm Rono Savio, and in this video we'll be discussing on how Python handles its errors. So basically error handling, where you are sure as a coder that you're gonna face an error, but how do you prevent it from stopping your code from execution? So that's what we're gonna discuss in this video, and let's dive in. So now we will see how to handle these errors. I'm gonna say, so you can see in my VS Code, I'm going to start with this try and except statements. So what is this try and except statement? So I'm saying try this code, and if it's throwing an error, like whatever error, like I know beforehand itself, I know that that error is gonna occur. Then if that error occurs, like run the code, like try, and you have an except statement. In the except statement you'll run another block of code. So let's say try, and then I said you have except. Okay, and inside this try I'm saying, let's take an example of zero division error, and I'm trying to, okay, this code, what I'm doing here is a division code. So I'm saying print this for the user to understand, it's a division code. Okay, and here what I'm gonna say is a int of input enter the first number, or let's say enter the numerator. Okay, numerator, that sounds better. Then I'm gonna say b, that is also gonna be from the user. I'm saying input enter the denominator. Okay, now we have to make sure that the denominator is not 0. So I don't have to write a logic and all for that. I just have to say except Python will automatically detect division error. When you, in the previous examples, when I was showing you the rank of those particular errors, you saw in zero division error, I was just writing the code and it detected that I have a zero division error. So what you do, when you just tell Python, when you detect this error, do this, like whatever code you want. So I'm saying that particular except statement that you're going to give is going to be in this particular line. So I'm saying except zero division error. So you already have this zero division error as E, and I'm gonna say print your denominator should be greater than 0. Okay, and if I want, I can print the error also. So the E is nothing but your zero division error, or you can customize your particular error into this. Now here I'm only printing a message. If at all you find, like let's say you have a huge code and you have some other logic to be written, you can write it in the except statement. It's totally fine. And here let's say I run this code now. It's asking me enter the numerator. So numerator can be something 79, I don't know. Then I can say denominator, I'm gonna go with 6, 7. Okay. Anyways, 6, 7, and it says division code. It printed, and I didn't give any output here. Okay, fine. We had to divide it, right? We forgot to divide it. So we are saying print A by B. Fine. Again, let's try it. We are gonna say 79, and we're gonna say 6, 7. Okay, it's working pretty fine. We're getting 1.17 something. Let's try again. So I'm gonna say 6, 7, and I'm gonna go with 0. See, now you print division code, and it went with your denominator should be greater than 0 division by 0. So this E is after this 0, what you are saying. That's why the sentence is a little bit off, or you can just print only E also, it's totally fine. But yeah, or in some cases you don't have to print your E also, like you just keep it aside. Yeah, so this is how your try and except statement work. You are literally catching that error, and your code did not terminate. That's the main point. It didn't stop your code from execution when it detected the zero division error. It caught that error and it run the except statement. Now in that except statement you can have further calculations, like you can say what can you say, you can say a plus b and you can give it to c. I don't know, I'm just randomly saying, and I can say print c. Okay. If I run this, same thing, 6 7 0, it went with 67 exactly. So this is nothing but this last few lines that I wrote here, like 2 lines, just to show you that no matter what error you are facing, if you are able to hold it from the except statement, then you can run the code without breaking that. Now I just showed you try except, but there is furthermore statements that you can add. One is else statement, just like your if else condition, you can add else statement for a try and except block too. And you also have a finally statement, like the word finally, that's a statement I'm talking about. So we'll see how it works. I don't want to confuse you guys, so I just kept it separate. So yeah, you can look at my screen, and here notice this, I have written a pseudocode for you, not pseudocode, like a clear picture of it. So here what it means is try block works when the code that might cause an error, like you put whatever code that you are doubtful or sure of that it will cause an error, and except will run only if the error is caught. That's what I have written here. Else statement runs if no error is being caught. Okay. And finally is a statement that runs the code no matter if the error is occurring or not occurring. That finally statement will run whatever is inside that finally block. Okay. So here we can see an example. So here yeah, I'm gonna give else statement here, else print this else block initiated as no errors were present. Okay, makes sense, right? So now if I run this 56, and I have to make sure there is no error present, so I'm not going to give my denominator as 0, so I'm going to give some 3 and run it. So you can see it went to this line executor, print a by b, you got 18.66. it didn't run this one because this except block only runs when the error is caught. And in the next line you can see it's run with the else condition, else statement. This else block initiated as no errors were present, right? Now what if error was present? Then else block shouldn't be running, right? So if I run this and I'm gonna say 45, I'm gonna say 0. So now when I give 0, your denominator should be greater than 0, division by 0. So yeah, I got 45 because this is nothing but this line of code. Yeah. So 45, 0. Yeah, division code, your denominator should be greater than 0. Yeah, this makes it more clearer. Like your else block didn't work. Now if I add finally is a block where you can literally say, I'm gonna print what it's gonna do exactly. I am gonna be executed whether or not the error is occurring. Okay. So if I run this, whatever happens, 56, let's say you have an error, it runs, the finally block runs, it doesn't care. If I run with no errors, 45 plus 54, it still runs. I'm going to be executed whether or not the error is occurring. So finally block is like, no matter what happens, I'm not going to listen to anyone, I'm just going to be executed once all these lines are done. That's how it is. Now here in this particular try and except block, you are able to catch one particular error. Now I'm just showing you an example with zero division error. You can try it with many other errors in Python. But now let's say you have multiple errors and you want to check if all those errors are being tracked down. You can create your customized errors. What do I mean by customized errors? I'll show you. So I'm gonna take this except block, try and except block from here. Control C and go here, Control V. So now what I'll do, I'll just alter it a little bit. this is only catching zero division error. I'll say I want to also catch value error, so I'm gonna give I can just ignore this line. I'm gonna say this is a list, L equals list, and I'm saying L of 10. So now L of 10 does not exist. I'm saying B, assign that value to B. Okay, and what I'll do, zero division error, and I can say comma. What's this one? What error is this? Index error, right? So I'm saying index error. You can see I have index error. Keep it in a tuple as E. So your denominator should be greater than 0, or maybe your list of index is out of range. I can tell this, I can customize my own errors. Now if I run this 45, 34, you can see I'm getting that error, or it's like either zero division error or the index error. If at all I'm giving the B value also as some value greater than 0, it is still throwing me an error because index error is occurring. So that's what this exception block is doing. It's catching two errors at the same time. Now you can see if at all I want to catch multiple errors, I can just keep on adding those errors here. But is there a way to keep it more simplified? Maybe giving an if condition, but if condition will make it like if, elif, it's gonna go till that else condition reaches. But there is one more thing that is called as assert statements. So we'll see how to use that. So what I do, instead of giving these things, I'm just gonna erase all this, and I'm gonna say I have A equals 10, very simple, B equals 20. Now I'm customizing my error, okay? Not even the default errors that Python has already, like whatever ranking we see. Here I'm saying I want my own customized errors, where if at all the particular value is less than what I want, then throw this assertion error. This error will be known as assertion error, as it's an customized error. So what I'm saying, assert A should be greater than 10. Okay, here A is equal to 10. It should be greater, I'm saying. And if at all the assertion statement is not satisfied, then you can put the message here, your variable A is not holding value greater than 10 with exclamation 10. Yeah, that's more better. So also make sure that this exception statement has assertion error here, ASS assertion error, and you don't have to print this. You can just say E, because that E what you're gonna print is gonna be this message here. So now I'll run this. It already says, okay, if I give 11, it works pretty fine. If I give 1, yeah, your variable A is not holding value greater than 10, exclamatory mark. Okay, so now you know how to use assertion error. And what's the use of this assertion error? You can see it's a one line statement what you have given here. The advantage is that if at all you wanted to give this in an if condition, you should have some if, elif, you should write multiple lines, which will make it more complex. But when you have assert statements, it's like just one line. It makes it more simplified. You can give multiple assert statements and your code will look organized. That's the reason why you use assert statements. And yeah, you use this with exception handling like this. And you can have multiple assert statements. You can say A assert B equal to 20. And if it is fine, then good. I mean, this message what you're giving here, it's the error message. If at all it's not satisfying the condition, then you give this error message. You're gonna say make it equal to 20 for B. Okay, and if I run this, it's fine because B is 20. I'll make it 21 now. And variable is not holding the value 10. Oh, okay, the first error. The first error is still occurring because A is 1. I have made sure that the first assert statement is like A is greater than 10. So I'm going to give 100. Now the second assert statement. Make it equal to 20 for B. So you can see how many errors you can customize here. Depending on the situation, you can just keep on changing. Even if it's a zero division error, you can customize it using assert statements. That's how powerful it is. You can also use raise keyword to raise an error. So I'll show you that. It's used with if conditions normally. So let's say you are trying to verify the age. So here I'm gonna say age equals 11, and I'm saying if age is less than 18, okay, I'm raising now you say value error, and I'm gonna say this, okay, you're customizing it also, this is invalid age. Okay, if I run this, you see it has given this particular. If I give 19, it works perfectly fine. So I can say print eligible. Okay, if I say again 17, value error. You can use raise keyword too, and not only value error, you can have all other errors that I showed you before in the ranking system. And you can also create your customized errors using Python. You can create a class. You can say class, and I'm gonna say my personal error, and I'm gonna pass in exception, exception, and I'm gonna say pass, and same thing, age equals 18, and I'm gonna say print, if age less than 18, right? Okay, if age less than 18, I can say raise, same thing, raise. I'm using the raise keyword, and I'm saying my personal error. So this exception is the common base class for all non-exit exceptions. You don't have to focus much on that, but yeah, you are creating your own customized error here. So what I'm gonna say, my personal error, and I'm gonna say, yeah, this is invalid, and yeah, this should be 17 in order to trigger that error. You can see here it was value error. This is Python's error. Here you see it's my personal error. It's about the age. Yeah, this is how you can work with it. You can create your own personal errors. So that's all for this video. I hope you found this helpful. If it did, do subscribe and take care. See you in the next one. Thank you.